Hey all, I'm Sam. I'm with Scully Group, and I'm going to be showing you virtually through the CESE Lab some of the equipment used by Dr. Scully, Dr. Kelly, Dr. Zingari, and Dr. Burns to a limited extent. Sorry you can't be here with us in person, but want to thank you for coming along. We're going to do the best we can to give you the real-life experience of being here. So it's going to start with sample preparation, which this is the first room in our lab series. And first step is going to be epoxy mounting. We have a system here for line-up epoxy as well as plenty of molds. And then we can take this through over here on your left to any hardware systems that may be necessary, all your drilling, cutting. And a lot of times this is essential as we're going to mount our samples with wires so that we can run an electrical current through them. A lot of the CESE goals is examining some of the corrosion, electrochemical behavior. How is the physical and chemical response going to respond to an applied electric potential? So as I mentioned that, we're going to be starting to enter that room where we start to get into some of the nitty-gritty electrochemical testing. On your left here, you're going to see two potentiostats, P1 and P2, and this is the conventional electrochemical setup where you're having a working encounter electrode. So by applying a potential or applying contributions of potentials, sometimes you can even set off the alarm button for the fume plant. You can also measure current that goes through to measure how many ions, the ionic dissolution rates, as well as how resistive is the passive film that's forming. So we have potentiostats here as well as a set up computer system that can analyze and keep track of the measurements in situ, as well as a 12 gauge on your right here in case you need to be running long-term experiments. So there's never a shortage of potentiostats, which is a good situation to be in. As you can see on your left here, sometimes we even create and design our own cells for when a common system isn't necessary. So we're going to start with these conventional cells, but in this case Alan is working with some measurements of the fluid layer, how the absorption is going into his aluminum system, so keeping track of the liquid layer through this custom designed graduate cylinder. There's plenty of gas that can be coming in and out as we come into our next room. So this is where a lot of our solutions are being made, mainly because we're testing the different electrolytes, the different concentrations of sulfites, chlorides to examine the effect of the attacking solution. So we have plenty of equipment again for that as we approach the solution making area. You're going to see various ways to adjust your concentration. Safety first, of course. As well as the pH. You're going to see a pH probe on your left to adjust the hydrogen proton concentration of your electrochemical solution, and then we can examine how that is going to affect, in addition to the applied potential, the response of the metal. So now we're going to be coming into our last room in Wilsdorf Hall, which is the main series. It's the larger of the two lab setups, and this has additional fume hood space for a bit of our longer term experiments, as well as a furnace system behind you as we come around. Do limited heat treatment work. And finally, you're going to notice on your left here, we're going to come up to the Tds Room, which is done in work of Chuck. You're going to find him under the group page as Charles DeMars. Unfortunately, it's locked right now. But if you have any interest in TDS work, I would recommend shooting an email to him to find out more about CESE's work on that.
Hi everyone, my name is Dwayne, and I am a PhD candidate in Robert Kelly's group. And today I'm going to be showing you some of the other tools that we use in the Center for Electrochemical Science and Engineering. So over here, we have a humidity and temperature control chamber. It's really neat because we can really program different combinations of humidity and temperature, so you can see how alloys will behave from a corrosion perspective under these different environmental conditions. So over here, we have something that we call a PFOD. It's a Cichlid corrosion tester. And the nice thing about this device is that we can use it for atmospheric corrosion testing. We can can use different ASTM standards, such as G85 and B117, to see how alloys behave under certain conditions of humidity, temperature, and then we can also apply a dry condition, and we can apply a spray condition just to see the electrochemical behavior of certain alloys under these spray conditions. Conditions that you might see in certain maritime or aerospace environments. So over here, we have an ultraviolet radiation chamber. This one is really neat because if we wanted to see how certain alloys behave under UV light, you can just place the alloys within this this chamber over here, and then we apply your UV light, and then we can see how they will behave under those environmental conditions.
So now we are across the way in the newly renamed Jesser Hall, which is just a very quick skywalk, environmentally protected walk away. So all our labs really are pretty close together. You're going to see in this lab, we do have more tensiostats, as well as on your right here, an opportunity to dispose of chemicals, acids, and bases. So that allows you to do really all your work here as necessary, particularly as most students in CESE have an office over in Jesser Hall. As you continue this way, you're going to see another fuel hood for some of the more toxic work, being with some of the more dangerous chemicals. I don't work with these. I'm very accident prone, so thankfully they didn't get any of those. As well as we set up an ultrasonic heater, drying oven, any of your short-term things that really would just be sped up by being able to have in lab. We were taking the steps to implement that and save time on the tests. Finally, as you come in, you're going to see on your right here the glove box, and that's most studied by one of our graduate students, Lon, so feel free to shoot him an email if you have any questions about that work. But this allows the safe preparation, safe use of chemicals that would not require ventilation, as well as has the opportunity to be turned into a vacuum. So we're going to take you to one more room throughout the third floor of Jesser. As you can see, a lot of our offices are down this hallway here, so you are really quite close to the labs you'll be working in, which can be a bit much safer, even though you don't really realize it all the time. Then finally, as you come around this corner, I'm going to try and take you to the chromate lab if I can get my keys to work. So this works with sodium chromate inhibitors, mainly done by the work of Tds, so feel free to shoot her an email if this is something that piques your interest. But by implementing dissolved chromate chemicals, you can slow down the reaction rates by both manipulating the corrosion potential as well as the corrosion current given by the potential theory. So this is kind of the last lab that is commonly used by CESE. There are some that are specific to Dr. Zangari's group or Dr. Burns' group. They have some of their own labs, so feel free to reach out to either of them with more interest in those topics. But I want to thank you for hanging in throughout the entire time. And once again, sorry you can't be here in person, but if there's something we can do to help you find out more about CESE or any of the specific professors, feel no hesitation to work out. Thank you.